Children's, so we'll start today's topic related to motion. So let us see a recap of previous topic we have seen, which is very important for you, and these are basic quantities, basic physical quantities we have learned, okay, that is important for our chapter motion. So let us just see which topic we have already seen. So very first we have understood distance. What is distance? Distance is the actual length covered by an object. Then displacement. So displacement is shortest distance between initial and final position is known as displacement. Then related to distance, speed. Speed is what? Distance per unit time. Distance per unit time. Okay. So speed is totally dependent on distance. So if you know distance of particular object, you can find its speed by knowing its time. In how much time particular distance has been covered, that is known as speed. Its SI unit come meter per second. Then we have seen displacement, and another physical quantity related to displacement is velocity. So displacement is shortest distance between initial and final position, and we can say it is having a particular direction, or it is moving in a particular direction or in definite direction. Okay, so displacement, so velocity is depending on displacement, means displacement per unit time is known as velocity, and the displacement is going in that particular direction, so velocity will also have that same direction here. Its SI unit comes the same, meter per second, meter per second. Then after that we have seen acceleration. Acceleration is related to velocity. So what is acceleration? Acceleration means change in velocity per unit time is known as acceleration. Okay, change in velocity means here u is initial velocity and v is final velocity. So whenever we are talking about change, it will be always final minus initial. Here we are having change in velocity, hence it will be final velocity minus initial velocity upon time. So this is acceleration. It's what is velocity is unit meter per second and time unit is second. So it becomes meter per second square. So this is unit SI unit for acceleration. Okay. So we have seen till here basic concepts related to motion. These are 4 physical quantities that we have read till now. We have seen till now. Now let us see, if we are plotting graph of these particular physical quantities, what type of graph we can get. So graphical part is very important for you children to understand how the motion is. Okay, by graph you can easily tell that whether the motion is uniform or non-uniform, or you can calculate by graphical method also. Okay, so you can directly see by solving the problem method. Already we have gone through one problems related to velocity, only acceleration problems we have not taken. So at the end of the chapter we are going to see each and every problems related to distance, displacement, total distance, then displacement, velocity, acceleration. We'll go through problems. Just now we'll see theoretical part. Okay, so we'll see now graphical method. Okay, so how to draw graphs, or what is the importance of graph? Already you have learnt in mathematics how to draw graph. So you know that it is having 2 axes, one is x-axis and y-axis. Okay, so it's very important. You just need to pay attention how to draw graph, because it's few things are very simple, but you should know it. Okay, many times this happens that we forgot to write, but while writing graph, few things are very needed that should be written here. So here this is x-axis, this is y-axis. Okay, you children know that this is positive x-axis, this is negative x-axis, this is positive y-axis, and this direction is negative. So when we are plotting, so this will be definitely 0. 0 is called as origin. Okay. So from here we'll start. Suppose here 1, 2, 3, 4. So it is plus 1, plus 2, plus 3, plus 4. And while writing here, what we are going to write here? Minus 1. Here plus 1, plus 2, plus 3, and in downward direction it is minus 1, and so on. Okay. So suppose table is given to you related to distance and time. Okay. Suppose here time in seconds and distance is given in meter. Okay. So fixed amount of time is given to you, that is zeros. Suppose 5, 10, 15, 20, 25, 30. Okay. And here suppose it is 0, 5, 12, 18, okay, 22, 30, 34. Okay. So from the table you can recognize the difference in the distance given to you. What we did? So from this table you should able to tell what actually is happening, what type of motion we are getting. Okay. So see, very first you have to see these two columns. One is time, another one is distance. So you can see that what is the difference of time here? 5. Here 5, 5, 5, 5, 5. Means after each 5 seconds, we have measured the distance covered by that particular object. Okay. So at 0 second, or its origin we can say, from here we have seen initially the position of that object is origin, or we can call it as reference point. In very first lecture I have told you about reference point, origin. Okay. Then after 5 seconds, the distance covered by an object was 5 meter. 5 meter. It is given in meter and time is given in second. After 5 seconds, it reached to 12 meter. Means from 5 to 12. In 15 seconds, it reached to 18 meter. 20 second, 22 meter. 25 second, 30 meter. And at 30 second, it reached to 34 meter. Now, you can observe here the difference is changing. It is not uniform. How? What is definition of uniform motion? Equal distance in equal interval of time. Here we are having equal interval of time, but here we are not having equal interval of distance. So hence this motion is non-uniform motion. So from the graph, from the table given, this is the information given to you. From this you can identify that the motion is not uniform. It is non-uniform motion. Okay. But also we need to study more things related to that. So for that you need to draw the graph. Okay. So for graphical method we have to draw two axes. Okay. X-axis and this is y-axis. I'll erase this graph. Okay. This is origin. You children know that origin means your points of 0, 0. So this is point of x-axis and this is point on y-axis. So this is 0, 0. Correct? Now, it's very important out of these two quantities, I am repeating it. It's very important out of these two quantities, which should be written on x-axis and which should be written on y-axis. So you have to check that which quantity is dependent quantity and which quantity is independent quantity. So there are two quantities here. One is dependent, another one is independent. So generally time is said to be independent quantity. Okay. So every time on x-axis you need to write independent quantity, which is not depending on anything. That is called as independent quantity. And another quantity, that is dependent quantity, should be written on y-axis. Again I am repeating, independent quantity must be written on x-axis and dependent quantity must be written on y-axis. Okay, so it's very simple. This interval is fixed. It is independent. Okay, but distance is depending here on time. Means at what time we are measuring the distance. So hence distance is depending on time. After 5 seconds, I can change it to 10 seconds. I can change it to 1 second. Okay, so time is independent. It depends on me. It depends on distance is depending on this particular time. Means at what particular time interval we are considering, according to that we are measuring the distance. So this is the quantity which we are measuring. This is fixed. Okay, so we can also say fixed quantity will be on x-axis, and which is not fixed, which may change, will be written on this y-axis. So generally time is independent quantity. So all the time whenever graph related to time, and another quantity may be distance, displacement or velocity, correct? The time will always be on x-axis. So you have to remember this thing. So here we have to write time. You have to show this time like this, or if you give it small letter t in the box, so you can write here t. So small t is representing as time with the arrow direction. This is very important to write, and this is distance. Okay, so distance in this direction. Okay, so here units are given. Here it is in second, meter. Maybe it in few of the graph you can observe here it time is in minute. Okay, distance may be in meter or kilometer. Here it is in hour, it may be in kilometer. Okay, according to graph we will observe different graph. So here distance is given in meter and time is given in second. Till here everyone understood? Now let us go further. Time is given 0, 5, 10, 15, 20, 25, 30. So you know that there are grid. You can see after just there are like these dark lines on your graph paper. Each one grid will have how many lines? 10 lines. And one will be shaded some little faint at 5. 1, 2, 0, 1, 2, 3, 4, 5. This is 6, 7, 8, 9 and 10. Okay. So here also you will have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here we are having faint line. One faint line. Here we are having one faint line like this on your graph paper. Okay. So children, you have to first write this on the table. So it depends on you how you are taking the difference. Suppose of each individual box I am considering it as 5 seconds. Okay. You know how much it is total? Okay. So it's 5. Then next is 10. Then we are having 15. Then we are having 20. Then another difference is 25. And here we are having suppose 30. Okay. Now your difference is not exact, so we can take, so 0 to 5, 5 to 12, 12 to 18, according to you, you judge. Okay, so suppose I am taking here also 5 difference, each box of 5 centimeter, each box of 5 centimeter, each box of 5 centimeter, each box of 5 centimeter. Okay, so this is 5 second, 10 second, 15 second, 20 second, 25, 30 second, and this is 5 meter, 10 meter, 15, 20, 25 and 30. Okay, so if you draw graph, it's very simple. You have to check at what time what distance is covered, and according you have to mark it. Okay children, so at 0 time, how much distance was covered? 0. So this is your first marking, 0, 0. Next point is x, y. Okay. So first reading is 0, 0. X axis means time and y axis means distance. Okay. Second is 5, 5. Means x axis 5 and y-axis also 5. So you have to draw at 5 second. Here it is meeting these two perpendicular line. So this is your second point. What it is? 5, 5. Means at 5 second how much distance was covered? 5 meter. Next is 10. X-axis 10. So your third point is at 10 second. Y-axis is at point on y-axis is at 12. Okay, so you know that in between how many lines are there? 10 lines are there. Okay, so 10 to 15, how many lines are there actually? How many meter difference is there? Of 5. Okay, so 5 meter makes this one particular box around 10 lines. So how to check which will be your 12? It's very simple. See, this is 10. You can't take it as 11, 12, 13, 14, 15. No, you can't take it. So what you have to do? You have to take now 2 lines. So this will become 11, 12. So I'll first draw 10 lines in between that so that it will be easy to understand. This is 11, 12, 13, sorry, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is the 10th line. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now suppose this is 11, this is 11, this is 12, this is 13, this is 14, this is 15. Okay, so 2 lines will make 1 meter. I am repeating, 2 lines will make 1 meter. How I understood this? How many distance here we are having of, what is the difference of the distance here of 5 meter? Correct. And how many lines are in this particular one box? 10. Okay, so 5 ones are, 5 twos are. So how many lines will make 1 meter? 2 lines of the box will make 1 meter. I am repeating this process. It's very important. You have to check. You children already know that in one box there are total 10 lines. Okay, and this total, we can say this 10 lines, you have to divide by what is the difference of your distance you have taken here. Okay, here what is the difference? 15 minus 10, 5. So it becomes what? 2. So 2 lines will make 1 meter. 2 lines will make its 1 meter. Okay, so this becomes 10. After 10, this 2 line 11. So after 10, you have to take 2 lines. That will make 11. After that, you have to take 2 lines. It will become 12. After that, you have to take 2 lines. It will become 13. After 2 lines, it will become 14. And after 2 lines, it will become 15. So 2 lines will make 1 meter. So it's very simple. Your second point is 10, 12. Means at 10 second, how much? 12. Just now we have seen this is 11, 10, 11, 12. So here will be your point coming. Understood? So here this is your second point. Suppose you may label it. Suppose this is A. You can take it as O, A, B. Okay. Now next point is 15, 18. So X 15 and Y 18, means on y-axis you have to take 18 and on x-axis you have to take 0.15 centimeter. Okay, so 15 centimeter, again the same thing what I said, 2 lines will make 1 meter. So here we are not using a particular graph. So how it will become? 2 lines will make 16, 17, 18. Suppose this is the 18. So this is your C point. Then 20, 22. 20, 22. Consider 20. This is 21. This is 22. I already said 2 lines will make 1 meter. So this is 22. Then 25, 30. At 25, it comes to be 30. Okay. And at 30 seconds, somewhere it is coming 34. So this is the graph. Okay. So this graph is uniform or non-uniform. How to check? Go on joining these 2 lines. Okay. Okay, children. So it's very simple. It is non-uniform motion. Why? Because you can observe the graph is not coming straight. If the graph is coming straight, so that graph is called as uniform motion. But it's very simple. If I ask you from the graph whether the speed of particular object is increasing or not, what should your answer come? Yes, speed is increasing. How you come to know? From the graph itself, you can see that the graph is raising. It's not uniform motion, but you can observe the graph is increasing. It is not going like this. If it is going like this, then that means it is decreasing speed. But here we can observe that speed is increasing. Okay, so this is the way to draw graph. So if you don't have any idea, just graph is given, from this also you can easily tell what is the distance covered in particular time, means after 5 seconds, 10, 15, 20. If I measure this, I can easily tell that the graph is at what second or at what time, what was the distance covered by the object. This is the first thing you can identify from the graph. Secondly, you can judge what type of graph it is. It is uniform motion or non-uniform motion. Okay, if the graph is going like this straight, that means it is what? Uniform motion. If it is not going straight, it is going crooked line, then it shows that it is non-uniform motion. And also you can find at what time what distance is covered, or you can tell that this is the particular area that you was having uniform motion. Here you can say it is uniform motion, then it is non-uniform motion, and many things you can find from it. Okay, so this is very simple graph related to distance and time we have seen. You have to also write the scale. Okay, so this is 10 lines. Here also we are having 10 lines in one box. Horizontally also and vertically also we are having 10 lines, and this particular one box is of 1 centimeter. Okay, so how to write scale? Scale on x-axis. Okay, 1 centimeter is equal to 5 seconds. Correct? One box is of 1 centimeter, and here we have measured of how many difference? 5 difference. What? Of 5 seconds. So this is one x-axis 1 centimeter is equal to 5 second, and on y-axis it is 1 centimeter, again here 1 centimeter of 5 meter. What difference we have taken? 5 meter. So this is the whole method, whole process of solving the graph. So on graph there will be lot of questions based, okay, not only to your basic 9th class, but in 11 12 there will be graph. If you want to go for engineering or medical or IIT, there will be graph you have to check. So very important part is how to read the graph. If only graph is given, you should be able to read. Very first, if directly graph is given to you, you have to check what physical quantities are given on x-axis, y-axis, what are its SI units, then what type of graph it is. Okay, it's simple distance and time graph, so it will explain you what speed. So this is nothing but what? Speed of your particular object. The object given what type of speed it is having, and from this lot of things you can explain. Okay. So this is very simple graph we have seen. Now we'll go for another type of graph if it is related to speed and time, or velocity and time graph will explain you acceleration. So in the next class we will see another graph. So this is very basic graph I have told you. In each graph again I will explain the same topic so that you will be able to identify graph and solve lot of problems, because related to this graph we are going to study very important part of the chapter, heart of the chapter that we can say, that is equations of motion, Newton's equations of motion, and that are really needed to you children to know related to this topic. Okay, so don't miss that part. So for that, important is graph, how to read graph, how to draw graph, what things should be given, what things are necessary for that. So if you are drawing this graph at home, you better try on a graph paper, so that you can identify, understand, and when drawing the graph, go by step, what I said, independent, dependent, how to take these lines. So in your graph paper you know that there are 10 lines, one is faint in between these two lines, so that is counted as 5. That is fifth line. So if you want to know, so this is the difference I have taken. You can take any difference, you can go by this also, 0 to difference, 4 6 8, or you can take 0 10 20, anyhow you can take. Okay, so according to that, but you have to make sure how many, just this is total 10 divided by how many lines are here, 10 lines, and divided by number of, what is the difference between these two, this is 5, so I have taken 10 divided by 5, it comes 2 lines. So 1 meter makes how many? 2 lines will make 1 meter. So like that, according to your measurement you can take it. Okay, so for today's topic this much is sufficient. In the next period we'll see another graph, velocity time graph, if it is given in kilometer per hour or if it is given